Okay. Bismillah ar-Rahman ar-Rahim. We'll continue. We'll finish those problems with the exactness. Now we'll go to the substitution method. The idea is what? By a specific substitution, I will change the differential equation either to linear or separable. As I said before, each method, it has a criteria or format, and then after that, there's a procedure to solve it by doing some substitution in this case. So we have three things. We have homogeneous equations. I will explain it, where it has a specific format. And by a specific substitution, I'll change it to separable, then I solve it. Bernoulli, specific format, then you will find, then by specific substitution, change it into linear. The same thing of this form. I can't transfer it into separable by using a specific substitution. Let us now deal with the homogeneous equations. Before I start the homogeneous equation, this is the format usually we deal with. We need to define something when we say the function is homogeneous of degree alpha. So I need to define what's I mean by homogeneous of the same degree or degree alpha. So I'll check m tx ty. It's equal t to the power alpha m of x and y. Then we say m homogeneous of degree alpha. Or check n also, tx ty. If I can take the same alpha, the same t to the power alpha as a common factor of n x and y, then we say n homogeneous of degree alpha. If both m and n are homogeneous, where it means I can take t to the power alpha as a common factor of the same degree, then we say the equation, the differential equation, is homogeneous. How to solve it? Easily, I will use this substitution. If I will put y equal ux, which means dy is equal to this, or I will write x equal vy, which means dx equal to this. That's it. This substitution will change the equation into separable. For sure, this will make it separable equation. Okay, let me do an example. First, we need to be sure that we understand what we meant by homogeneous of degree alpha or of the same degree. Okay, let me do this one. I have this one m of x and y. This one n of x and y. As we usually do, I mean, I will try to explain it more and more. Yeah, in more details, I mean, so that we understand it. Okay. Now, I need to check first. This m, is it homogeneous? By the way, this is not the way the book is doing it. I'm doing it. This is like I'm following Zell book, not our book. Okay. So I have m of tx, ty to check is it homogeneous or not. I mean the function m, is it homogeneous, and what is the degree? And also I'll do the same for n. Now I have, instead of x, I'll write t square x square plus t square y square. I can take t square common factor, so I have x square plus y square. So it will be t square m x and y. This is the same function. So it means m is homogeneous of degree 2. Let me do the same for n. That will be what? This is my n. It will be t square x square minus tx times ty. And that is what? T square x square minus t square y square. So I can take t square or common factor, which is t square times n of x and y. So n is also homogeneous of degree 2. If they are homogeneous, this is the criteria. If they are homogeneous, if both coefficient matrices are homogeneous of the same degree, right away we say the equation is homogeneous. Differential equation is homogeneous. How to solve it? This substitution or this substitution? Is there a preference? No. I mean, they are preferences. If I have different number of terms here I have the same number of terms. Yeah. This is one thing. And the other things, sometimes the integral will be complicated. So you need to be careful about this. So let me start with let u equal ux. What will be dy? Y equal ux. What will be dy? It will be u dx plus x du. I plug this and this, I plug it into the equation. So the differential equation becomes what? This is x squared. Y squared will be u squared x squared. Dx will be dx. X squared. When I see y, I will change it into ux. That will be ux squared. Dy. You notice my new equation, I have only x and u. I don't have anything else. I have only x and u. So let us now see what will happen. That give me what? X squared dx plus u squared x squared dx. U times x squared dx plus x cubed du minus u squared x squared dx minus u x cubed du equals 0. This is cancelled. Okay, what I have in terms of dx, I have x squared 1 plus u dx. Let me take the du to the other side. I have what? X cubed du. I have 1 minus u. Take the other side, that will be u minus 1. So let me write it this way. X cubed u minus 1 du. Now it seems I'm going to a separable one. That means dx over x. I divide by x cubed, and then I'll divide by 1 plus u is equal u minus 1 over u plus 1. U minus 1 over u plus 1 du. Very clear, this is simple. Since it's homogeneous, this substitution, as we said, this substitution or this one, will change it into summary. Now I solve it as summary. Integrate. So I have, ln of x equals what? You can't deal with this one. You can do this trick. I make it u plus 1 minus 2. So it is 1 minus 2 over u plus 1. These tricks in dealing with the integral. So now what will be the integral? That would be u minus 2 ln u plus 1 plus c. Okay. Now I take e both sides. So I have x equal e to the power c, which is c, e to the power u times what? This will go as the power u plus 1 to the power minus 2. Okay. That give me what? That give me x times 1 plus u squared equals c e to the power u. Okay. Now I need to return u, I need to write in terms of u. This is in terms of y. I need to find the solution in terms of y and x only. So I have what? X 1 plus y over x squared, or u is y over x equals c e to the power y over x. So we have what? We have x. I have x times x squared plus y squared over x squared equals c y over x. Or I have x squared plus y squared equals cx over x, which is this one, which is my solution. So that will be my solution. So that's the idea. Checking it's homogeneous by doing these homogeneous with the same degree for both m and n. This substitution, transfer it to separable, solve it, done. Another problem. This one separable, this homogeneous. This, let me check. This is m and this is n. M of tx and ty. It will be what? Ty. So this is homogeneous of degree 1. What about n? That will be tx ln tx minus ln ty minus 1. Is this homogeneous? I have ln. Oh, you need to notice something. That will be tx. This is ln tx over ty minus 1, which is tx ln x over y minus 1. Well, this one you can write it x actually ln x over y minus 1. So I have t. So it's very clear this is homogeneous of degree 1. So it's homogeneous. So the differential equation is homogeneous. I have homogeneous differential equation. Okay. So I yeah, I think I need the x here. The x will make it easier. So let x equal vy. What will be the x? V dy plus y dv. For sure, the new equation should be yeah, the new equation should be a separable equation. Okay, substitute. We have what? Y. I don't. Y will remain. I will change x. Dx will be this. Yeah. When we say is there a reference? Yeah. When we ask is there a reference for these two? Yeah. Sometimes one reference depends on what. Look, when you have dx or dy, you have two terms, dx and dy, two terms. So in this case, if I use dy, it means I have 4 terms. I'm getting 4 terms here. But if I use dx, I'm getting only 2 terms. 2 times since I have the m, which is the coefficient of dx, is only 1 term. N is 3 terms or 2 terms if I make it ln x over y. But still, dy use 2, that means that will make this, when I do the product, it will be 4 terms. But here, it will make it only 2 terms. So this is one way to think about which method to do. The other things, when it go back to separable, it means you need to integrate. Sometimes you need to be sure this you can do the integration. Okay, so because of that, I took x equal vy. So that will be what? Plus vy ln x, which is vy over y minus 1 dy. That's equal to 0. Now let us do the calculation. Yv dy plus y squared dv plus vy ln v dy minus vy dy equals 0. So this is cancelled. So it's very clear this is separable. So I have what? Vy ln v dy equal minus y squared dv. Yeah. So it means what? I have dy over y. I divide by u squared equals dv minus dv. With the minus, with which one? Yeah, I can put the minus here. That means minus dy over y equals dv over v ln v. Okay, very clear separable. Now I integrate. You have what? Yeah, what's the integral of this? I take u ln v, du will be what? dv over v. So this will be integral du over u, which is ln u, which is ln v. So I have ln of ln v, ln of ln v equals minus ln y plus c. Take a both sides, so I have ln v equal c over y equals c over y. Yeah, I have e to the power minus ln y, to take y to the power minus 1, so I have c over y. Okay, so that means c equal y ln, instead of v, I will write x over y. Okay, I have initial condition. Let me try to find the initial condition. So this is now my solution, but I need the initial condition. Y at 1 equal E. I'm getting what? E equal what? E. No. C. Not even E. C. I need to get C. Huh? C equal what? E ln 1 over E, which is minus E. So I have Y ln x over Y equals minus E. Or can write it y ln x over y plus E is equal to 0. So this is my answer. Okay. Let me do more problems for the homogeneous. Yeah. Okay, I need to rewrite this one first. Okay. I have what? dy over dx. I give it more space. 2y to the power 4 plus x to the power 4 over x by cubed. So I have what? Let me rearrange it. Yeah, you can check. This will be m. This will be n. This is homogeneous of degree 4, by the way. Yeah, actually, we're dealing with the power. I have 4. This is 1 time 1 plus 3, which is 4. So it's homogeneous of degree 4. So the differential equation is homogeneous. I have homogeneous differential equation. Now I will let dy. I think it will be easier if I'm using y. I'm using dy, yeah. So I let y equal ux. That means dy will be u dx plus x du. Why I'm doing this? Because I have only one term here. Okay. So let us see what will happen. Substitute. Instead of y, we'll write what? 2 u to the power 4 x to the power 4 plus x to the power 4 dx. Okay. Minus x u cubed x cubed times this is the dy. So I have what? 2 u to the power 4 x to the power 4 dx plus x to the power 4 dx minus x to the power 4 u to the power 4 dx minus x to the power 5 u cubed du equals 0. Okay. Yeah, some people sometimes ask, is it always when you do substitution, there is something cancelled? Sometimes yes, but sometimes no. There is nothing cancelled, but there is, yeah, this one is similar to this one. So you need to subtract it. That give me what? X to the power 4 dx. Yeah, let me do it in steps. U to the power 4 plus x to the power 4 dx. This will be this, and that will be the other side. Notice this one, I can take x to the power 4 common factor. The remaining is what? U to the power 4 plus 1 dx equal this. Okay. And that means what? I have dx over x equal u cubed over u to the power 4 plus 1 du. Now it's very clear, it's summer. Okay, now do the integration. I have what? Yeah, I can make this 4 over 4. If I take this as u, so I have ln absolute value of u, absolute value of x equal what? 1 over 4 ln this. Don't forget plus c. That means what? Take e, I have x. You can take e to the power c plus or minus c. We know this trick. That will be c. One plus u to the power 4 to the power 1 over 4. I take e, so that will go to the power 1 over 4. Okay. And what is u to the power 4? U to the power 4. U, what is u? Y over x. So that will be y to the power 4 over x to the power 4 to the power 1 over 4. Take x to the power 4 from both sides. So I have x to the, take to the power 4. Take to the power 4 both sides. I have x to the power 4. It will be c. C to the power 4 equality c. 1 plus y to the power 4 over x to the power 4. So I have what? Oh, or can you know what? I can put the c in the other side. Yeah, that will be c. Okay. So I can divide by c here. You have x to the power 4 equal c x to the power 4 plus y to the power 4 over x to the power 4. So you have x to the power 8 equals c x to the power 4 plus y to the power 4. Let me divide by c, and I have the other side quality c again. X to the power 8 equal x to the power 4 plus y to the power 4, which I can write y to the power 4 equals c x to the power 8 minus x to the power 4, which is the same answer. Yeah, you can deal with it. 2xy dy by dx equal to this. Okay. Yeah, we'll do the same. Let me arrange it. I have, yeah, if you notice, this is power 2, power 2, power 2. So that will tell me, think about it as homogeneous. So I have 4x squared plus 3y squared dx minus 2xy dy equals 0. Okay. This is homogeneous of degree 2. This is homogeneous of degree 2. So I have the homogeneous differential equation. And I will use what? I will use dy. So I let y equal ux. So dy will be u dx plus x du. Plug it, see what will happen. You have what? Yeah, you have y, huh? I'm plugging y. 4x squared plus 3u squared x squared dx minus 2 x is y is ux, so that ux square dy, which is u dx plus x du. That's equal to 0. Now open it up for x squared dx plus 3u squared x squared dx minus 2u squared x squared dx minus 2u x cubed du equals 0. Okay, so I have what? 4x squared plus u squared x squared, because this is what I'm getting, times dx equal to u x cubed du. Or in other words, or I can take x squared common factor, I have 4 plus u squared dx equal to u x cubed du. In other words, I have what? I have dx over x equals 2u over 4 plus squared du, which is separable now. Integrate, I have ln absolute value of x. This is u, this is du. Ln 4 plus u squared plus c. In other words, that give me what? X equals c times 4 plus u squared. Yeah, I can take c the other way, like what we did. So I have x for cx equal 4. What is u? Y squared over x squared. In other words, I have what? C multiplied by x squared, cx cubed equal 4x squared plus y squared. And that will be my answer. Yeah. Okay. Now let me do this one. Yeah, it's not difficult. It's a little bit lengthy, maybe. Not like this. Okay. Yeah, I like to see the answers. Okay, rearrange it. I have initial condition. Okay. So I have y plus square root x squared minus y squared dx minus x dy equals 0. Is this homogeneous? Yeah, let me check this one just to m of dx dy will be ty plus, and what is this? Ty. I can take t common factor, x squared minus y squared. So this is homogeneous of degree 1, and this is very clear homogeneous of degree. So this is homogeneous differential equation. And I will let y equal ux. Since I have only one term here. So that implies dy will be u dx plus x du. Substitute, you have what? Ux plus x squared minus u squared x squared. This is times dx minus x times du. Okay, do the calculation. That means ux dx plus x square root 1 minus u squared dx minus ux dx minus x squared du equals 0. Cancelled. Make everything clear. So I have x square root 1 minus u squared equal x squared. Forget the dx. Dx equal x squared du. Divide. So I have dx over x equal du over square root 1 minus u squared. So I have ln absolute value of x equals sine inverse of u plus c. Okay, So I can have sine inverse of u, which is y over x, equal ln of x plus c. Okay, now let me use the condition. I have the condition. So y at x0 equals 0. That gives me what? Sine inverse of 0, which is 0, equal ln of x0 plus c. So c is what? Minus ln of x0. Oops. So I have sine inverse of y over x will be ln x minus ln x0. In other words, ln x over x0. So I can write it in y over x will be sine of this, or y equal x sine of ln. Okay, that will be my answer. Yeah, that will do homogeneous. We did homogeneous, we explained homogeneous. I need first to be sure it's homogeneous equation, then I use this substitution and this substitution. And I think we did good number of problems. Let me go to Bernoulli. Bernoulli is what? Okay. The same thing. I have a specific format. Notice this format is similar to the somehow to the linear. If n equals 0 or 1, then it's linear. If n not equal to 1, n equals 0 or 1, then it's linear. If n not equal to 1, then this substitution will reduce it into linear, and then you solve it. Okay. That's mainly the idea. Specific format, almost like the linear, but I have y to the power n in the other side, in the right-hand side. This substitution will change this differential equation, which is called Bernoulli, into linear. Let us do the examples. I have x squared dy over dx plus 2xy equal y cubed, which I can write dy over dx plus 2 over xy equal 1 over x squared y cubed. Look at this format, similar to this. And what is my n? Very clear. This is Bernoulli with n equals 3. So what is substitution? Let u, don't forget y to the power 1 minus n. It's y to the power minus 2. I need to find dy over dx, so I need to write y in terms of u, not u in terms of y. That means y will be u to the power minus half. I take minus half. Look, I mean, sometimes some people, they were confused with this. So I take minus half to take care of this exponent. So it will be y. This is u is minus half. This is the way to think about it. Yeah, as to deal with the exponent. If this is y, what will be dy over dx? It will be minus half u minus 3 over 2 du over dx. Plug things there. What will be the differential equation? This is dy over dx plus 2x. This is y 1 over x squared. This is us minus 3 over 2. Where I put y equal u to the power minus half. So now everything in terms of x and u. Now I need to get rid of this. So multiply by minus 2 u to the power 3 over 2. So I have what? Du over dx minus 4 over x u equals to what? Minus 2 over x squared. What is this? Very clearly linear. So this substitution, I change this Bernoulli equation into linear equation, which is easy to do. Okay, now I need to find the integrating factor. If I remember, that will be e minus 4 over x dx which is x to the power minus 4. You can do this. Yeah. Okay. That will be my integrating factor. Multiply the equation. So I have x to the power minus 4 d over dx minus 4x to the power minus 5u equal minus 2x to the power minus 6. This side, it's d over dx, x to the minus 4u. Now integrate. You get what? X to the minus 4u. What's the integral of this one? That will be 2 over 5. X is minus 5 plus c. That means u will be what? Will be 2 over 5x plus c x to the power 4. Okay. Which is what? This one I can rewrite it 2 plus 5c x to the power 5 over 5x, which is 2. 5c, I can call it c. Okay. But this is u. What is u? U is y to the power minus 2. I need everything in terms of x and y only. So I have y to the power minus 2 equals to this. Or I can write it y squared spherical of this. And that will be my answer. Okay, another example. By the way, if remember this example, we did it as homogeneous. The same one. Now I'm doing it as Bernoulli. So sometimes the differential equation, you can solve by different methods, not only by one method. Okay, like in this example, this is also a homogeneous, but no, I mean a Bernoulli differential equation. It's homogeneous and Bernoulli at the same time. Okay, let me do it. I know it. Okay. As Bernoulli, I rewrite the equation. I have what? Divide first by 2xy. You have what? Equals what? 2x over y plus 3 over 2xy. So that implies what? I can rearrange it. dy over dx minus 3 over 2xy equal to x y to the power minus 1. So very clear, this is Bernoulli with n equal minus 1. So I let u y to the power 1 minus u square. Yeah. Yes. So I have y u to the power half. Y will be u to the power half. So du dy by dx will be half us minus half du over dx. So I plug those there. What will be the equation? Will be what? Dy over dx, which is half us minus half du over dx minus 3 over 2x y, which is u to the power half, equal to x u to the power minus half. Now multiply by the reciprocal of this, 2u to the power half. I have what? du over dx minus 3 over x, sorry, 3 over x u equals 4x. This is very clear linear. What will be the integrating factor? E to the power minus 3 over x dx, which is x is minus 3. Multiply, so I have x to the power minus 3 d over dx minus 3x to the power minus 4y equal 4x is minus 2. So I have d over dx, x to the power minus 3u equal 4x minus 2, integrate x minus 3u. What's the integral of this one? Will be minus 4 over x. Or I can write it minus 4 since using power plus c. Multiply by x to the power minus 3. I'm getting what? U is minus 4x squared plus cx cubed. And what is u? U is y squared. So I have y squared equal minus 4x squared plus cx cubed. Okay, that will be my answer. Or in other words, I have y squared plus 4x squared equals cx cubed. This is simple. Another one. Just I'll finish this, then I will stop. Because as I said, I don't like to have long. Okay. This is thing very clear, very ready. It's ready. Y equals 3 y to the power 4 over 3. Yeah, this is very clear only. With n equal 4 over 3. So let u y to the power 1 minus 1 over 3, which is minus 1 over 3. That implies u minus 3 is equal to y. So I have dy over dx is minus 3, u is minus 4 d over dx. Yeah. Plug it into the number, into the differential equation. So I have minus 3, u is minus 4 d over dx. To the differential equation. Plus 6 over x. U is minus 3 equal 3 y, not y. U is minus 3, that will be u is minus 4. Multiply by minus 1 over 3, u to the power 4. What you will get? I'm getting du over dx. You need to be careful. Minus 2 over x u equal minus 1. Integrating factor is about this, which is x to the power minus 2. Multiply x is minus 2 d over dx minus 2x is minus 3u equal minus x is minus 2. In other words, this equal to this. Integrate. So you have x is minus 2u equal x is minus 1 plus c. Multiply by x squared. I have u equal x plus cx squared. What is u? That means y is minus 1 over 3 equal x plus cx squared. Or in other words, I can say y is 1 over this to the power 1 over 3. To the power 3. Huh? I take to the power 3. Yeah, or minus 3. Okay. So with that, I make it in the denominator, which is the answer. Yeah, there is only one method remaining, and then we'll go. Yeah. So let me do this one, which is actually, let me finish by this one, which is not Bernoulli, not homogeneous, but sometimes, yeah, I have this example, and I think also we have 3 problems in the exercises where just by inspection, you notice there is, if I took a specific substitution, I will transfer the equation into something I can do. It's something I can, so that I can solve the equation. So the equation will be easy to solve somehow. Yeah, and this is the trick there. So if you notice, if I let u equal e to the power 2y, what will be du over dx? It will be 2 e dy over dx, not this. So the differential equation becomes what? X du over dx equals 3x to the power 4 plus u. In other words, it's x du over dx minus u equals 3x to the power 4, or du over dx minus 1 over xu equals 3x cubed. What is this? This is linear. So just substitution by inspection, transfer the equation into a linear equation, which I can solve into a linear equation, which is not difficult to, which we know how to do. We did it before. That's mainly the idea. So sometimes there are some substitution which transfer the equation into something you can solve. And this is the idea of the substitution, where I transfer the equation into an equation I can solve easily. Okay. Yeah, let me continue. So integrating factor E of this, which is x minus 1. I need x positive, yeah. So I have x minus 1 d over dx minus x minus 2u equals 3x squared. Okay. Do the calculation. That give me what? D over dx over x to the power minus 1u equals 3x squared. Integrate. So I have x minus 1u equal x cubed plus c. So u equals what? X to the power 4 plus cx. What is my u? E to the power 2y equal x to the power 4 plus cx. Okay. If you want to find y, what you can do? Yeah. If you want to find y, take ln of both sides. So you have dy, 2y, I mean, will be ln of this. You need the absolute value to be, so this should be positive. Okay. So y will be what? Half of this. So this will be my y. Okay. I think I will stop now. Just the reduction, and then we'll do this reducible second order, reduce it into first order. Then I will go to the old exams. Okay, so I will stop now. We'll stop here because I said I don't like to have long videos. Let me stop the recording. Yeah. Where is it? Thank you.